Hi there, and welcome to Scratch. I'm playing a little brick basher or Pong game that I whipped up as a little example for technology teacher education at the BC Institute of Technology, and just showing how something like Scratch and its object-oriented programming interface is a great way for junior high or even high school kids to learn about object-oriented programming and create computer games. And if you're used to procedural programming like we do on an Arduino or something like that, you're going to find this is quite a bit different. You don't have to remember about where to put the semicolons, but all those things that you learned about brackets and ellipses and variables and how procedures work is going to be very helpful as we go through and do all this. Scratch is a great learning platform. I'm going to talk about the fact that it's got some deficiencies in it. You can see some of our collision detection in here is not 100% perfect, and yeah, there's a few other things like that. But for a learning platform, to get kids excited about sitting down and doing something in front of the computer rather than just watching the latest TikTok or whatever it is they're up to these days, it's pretty cool. You have to keep on top of things, and every now and then it goes boing, and you Anyway, let's take a little look at how something like this comes together. So this is your Scratch interface, and up in this window, you've got your practice window right here, and your stop and start icons to make that stop and start for you right in there. And down in here, you've got your characters, your actors, or sprites as they call them in here. But more correctly, perhaps these are your objects that are taking place in the game. And this is an object-oriented programming language. And what you're going to do is you're going to take each of these objects and you're going to give them properties and then set them loose inside the program and let them interact with each other. Now, there's some things that you do need to know. That the screen resolution right here is fixed at 480 wide by 360 high with 0, 0 right at the middle. So up in your top corner, you're going to come upwards. So that will be going up 180 in the Y direction. And over here, this will be negative 240 in the X direction. So you've got X and Y, but unlike some languages like processing that sets the top corner right up here and counts out this way and then counts down, here it starts in the middle. This side of your screen is on the negative X, and this side of the screen down here is on your negative Y. Up here is your positive Y. So it looks just like the graphs that the kids might be using in math class at school. Okay, so that's some of your positional information. When you start up, you're going to see a cat right in there, and we're going to flip over to that beginning screen and talk about how we got here. But I just want to give you an idea of where we're heading with this. So what we've done is we've taken the concept of a Pong game and broken it down into its three essential elements. Now, I'm using the ball. I'm calling this the sun because it kind of looks like a sunshine in there. And I've edited a little bit the rocks that come with the program to turn them into clouds. And I was looking for an umbrella and wasn't feeling particularly creative enough to go ahead and create an umbrella. So I thought a watermelon would be a suitably silly thing to bounce the sun off the clouds and try to chase the cloudy weather away so that it would be sunny out. Now, each of the elements of a game in object-oriented programming, you have to think about what they're going to do and how they're going to behave. And there's going to be some things that cause them to be initiated, and then there's things that cause them to keep on moving. In the background of Scratch is a game engine that runs at 30 frames per second. So that means every 30th of a second, uh, the cycle starts. So where we have a forever loop right here. Yes, I know I clicked on that. Thank you. Just stop right there. We have a forever loop right here. And this forever loop is going to repeat 30 times per second. And the same thing for our rocks and our watermelon. If we don't tell it to repeat forever, it might only repeat once and it will be over and done with in the first 30th of a second. So if you think about some of the programming that you may have done on an Arduino, you've got a void setup in Arduino. Well, right up here is your void setup. This part of the code before the forever loop only runs once, and it runs when the little green flag is clicked to start the program. Down here, we've got void loop. And it's not called void loop, but it does the same thing. You can picture void loop and the ellipses or squiggly brackets right in here. And this little arrow pointing back up to the top, that's your squiggly brackets down there. And this is all hugging these code components right in here in between those squiggly brackets. And when we've got an if statement right here, then once again, we've got this little hug going on right here, and everything in this bracket right in here, ooh, look, you can slide it around. Everything in there is controlled by that if statement. And everything in here is controlled by that if statement. And everything in here, which includes making a sound, is controlled by that if statement. You can drag things out and you can drag them back in. And so for people who are not text-based learners, maybe people who are more visual learners, this is probably a natural way to go, and they'll probably find more success with this. For your text-based learners, they'll probably feel as I do that it's frustrating having to come over to the side and scroll through all the different commands to find the command that you want and then drag it out here. And when you want to say if something, you have to drag this command out here, and then you have to drag a little box in there, and then you have to drag your variable in there. Let's get rid of that. You can just drag it back off the screen right over here. So anyways, what we've done is we've used these commands in here to come along and create a set of commands for our sunshine. It's going to move along. We've got a set of commands for our rocks. Now, they're called rocks, but we're calling them clouds in this aspect of the game. And the cloud is kind of neat because when I edited the file, I gave it two costumes. So our sprites can have multiple costumes. So if you want to make something look like it's walking, you can actually animate the costumes on here. I've just used the big cloud and the little cloud. Okay, and so we've got two costumes. When the cloud gets hit by the sun, it shrinks to a smaller cloud, and then it finally disappears. So you've got to hit it twice. You could have more costumes in there, and you could start out with a rainy cloud, and anyway, you can see where that goes. And there's also a sound editor in here, and the sound editor allows you to come in here and edit up your various sounds. There's that pop sound going on right there. Somewhere in there, there should be the boing sound as well. Okay, um, so a few other neat things that we're going to have happen here is that we're also going to clone some of our objects. So when you have an object such as maybe a bullet or a missile in a shooting game, you might have 3 or 4 or 5 or 6 billion bullets on the screen at the same time. That might load the processor down a bit. But what you can do is you can have one of those objects with all of the inherent properties of that object. And then what you can do is you can create clones of that object that go across the screen. So you'll notice that when we start the game, you can see the clouds all draw themselves right across on the screen right there. And if I start it and then I stop partway through, it's not quite quick enough to catch that I don't have them all drawn out. That's because this routine, when the green flag is clicked, is going to come in here and it turns on the sprite, makes it visible, it gives it a position to go to, and then I've got a nested loop in here. So if you've been programming Arduinos and you're familiar with for loops, then I've got a for loop right in here. This repeats 10 times and it is nested inside another loop that repeats 5 times. So I end up getting 50 clouds, 10 across, 5 up and down. Now, each of those clones then gets specific instructions. So when it gets formed on that screen right there, it goes into a forever loop. And there's a collision detection engine that's running in the background. That's part of the process that's taking place 30 times per second. And so we can ask, am I touching the ball? And then if that's the case, it goes pop and it can change the costume. So if we're already on the small rock, which was costume number 2, we just hide that object. And if we're only on costume number 1, then we just move to the next costume. Now, there's other ways that you can go about putting that in, but that was what I came up with when I was playing around with this. You will see if you play the game that there are some issues on the collision detection engine, and there may be ways to make it work better, but for what we're doing right here as a little introduction, we'll just accept that as a little bit of a glitch in the background. And given what Scratch is meant to do, it's okay if it's got a few little a few little cracks in it. Okay, and finally our little watermelon right here that is going to be our block for bouncing the ball back and forth. When we start the game, we give it a starting position, and then again we loop forever, and we check to see which key on the keyboard is pressed. And then if we move left, instructions to move left, we check to make sure that we're not going off the screen. And if we're not going to go off the screen, then we go ahead and move it. And if the right key is pressed, well, again, we check to make sure we're not going to go off the right edge of the screen. And if we won't go off the screen, then we go ahead and we move it. And I've got a funny feeling. I've told a few people that, Pong was the first video game that I ever played back in, I don't know, mid 1970s. And I'm pretty sure the programmers that wrote that initial Pong didn't have quite an easy experience as this. So let me go to a new project here, and I'll just walk you through how I ended up creating this project, and it might give you some ideas for a game that you could make on your own. Okay, so when you start, you end up with the cat over here. And the cat is the default character that comes with Scratch. And you will find all sorts of tutorials that show you how to make the cat move, make the cat walk, and move things around. And the cat's a great place to begin. So if you just want to try something, you can come along here and say, well, I've got the cat object in here. And so you need to take a look up and down all of your controls right here. You can scroll through all of them. Now, I find it a bit of a hassle to have to go through and scroll up and down on all of those controls. So I went online and I looked up just a little cheat sheet on Scratch commands. So I keep this open on my second screen. So if you look for Scratch tutorials or Scratch cheat sheets, you'll probably find something like this that helps you find the commands that you want. And what we're going to start with is we're going to go to an event, and when the green flag is clicked to start the program, we can make the cat doing various things. Now, again, whatever we put in here, the cat will only do once unless it's wrapped up in some kind of a loop. So if we want the cat to do this every time, here's a forever loop. So that's going to keep running 30 times a second for as long as we're running the program. And then there's all sorts of things that you can make the cat do. For instance, you can say uh, move 10 steps, and if on edge, bounce. So we've got that edge detection feature built right into there. You can click on the green and bang, boing. And the cat is now moving back and forth across the screen. You can also add a point towards mouse pointer. Okay, and you can point towards a number of different things. Right now, mouse pointer is the only option, but as we add other sprites to the game, more things are going to show up. So we can start them moving around there, and he's going to keep moving towards that mouse pointer but jam up against the wall so it never goes off the screen. Now, if you want to see that on the full screen, click on that arrow right there, and now you can get the cat. I didn't even realize that I made the cat chase the mouse. I am so sorry. That is a bad pun. Okay, let's go back over here and hit the red arrow while I atone for my bad punishness. Okay, we were going to talk about Pong, so I'm just going to get rid of the cat for right now. And so over here, we want a new sprite. And the icon to get you a new sprite is right down here. And there's a whole selection of sprites in right here. And some of them have various motions involved. So like I say, there's different costumes for each of them. So you can come along and pick a sprite that you might want to move around. And somewhere in there, I just went with plain old ball. But you could choose a basketball instead. Okay. Now our basketball is going to just sit there unless we give it some commands. So just like we gave the cat some commands, we need to give the basketball some commands. And I like to usually start when I'm designing a project like this. In the back of my mind, I'm thinking, okay, well, what are the different objects that I'm going to have? What are their behavior properties? And then before I start creating other objects, can I get the basic behavior properties of one of the objects worked out? So focus on that one object first, maybe your main character, and flesh it out a little bit so it starts to behave the way that you want. So let's take a look in here, and we need to take a look at our events. And so when we click on the green flag to start the game, we want our ball to do something. And we might want to give it some initial starting positions. So we can have it start right in here. And you could tell it to start in a random position, but that might mean it would start in the middle of the clouds up here. You could come up with a random function that gave you some random starting locations because you can use variables and you can use random numbers in here. But for now, we're just going to start it at 0, 0. And what we're going to do is we're going to point it in a direction. And you can see right out there that now that's 0 degrees, that's 90 degrees. And right in here, we can stuff a number in here. And somewhere down in here, if I take a look at my cheat sheet, there is a random. I think it's down in here. There's modulus and rounding and not. Here we go. Pick a random number so we can drag that in. You'll notice that the rounded end means that it fits in there. It's kind of like Lego. If if you've got a square end, there's no way that that is fitting right. Okay, the square end fit in there. Square end shouldn't have fit in there. Round ends go in round parts. Okay, and we saw that 0 degrees was out this way. So if we want it to start coming downwards, then we're going to start somewhere between 180 and 360. Now we'd like it to be coming down fairly hard. Straight down is going to be 270 degrees. So let's pick a random direction between about 240, okay, and 300 degrees. Okay, and so now we've given it some initial coordinates. This is the equivalent of our void setup in an Arduino program. And now we want to do our equivalent of a void loop in the Arduino program. So we have to come back to our orange section right here, which is our control, and drop in a forever loop. And then we're going to tell it to move. And we can tell it however many steps we want. But let's take a look at what happens if I click go now. comes to the wall and it stops. I think my angles are a little bit off. Okay, and that's why I like to work on one object at a time. You get a chance to work that out. And so um, let's just try changing our random number out here. I think we need to change that up because it's always moving off to this side. I must be off by 90 degrees. And let's change that up. What happens if we say between 0 to 90? Let's see what angles we get there now. Okay, 0 to 90 is sending it off to that quadrant. '90 to 180. And this is one thing I do like about working on this one at a time. 90 to 180 is kind of off in that quadrant. I'm going to stop that. And I guess what I really wanted was about 130 to, let's add 50 degrees to that 180, 230 right in there. And let's see if those flow. That's about good starting position for a Pong ball. Now, we run into a problem that when our Pong ball hits the edge of the screen, it just stops right there and then comes over to a little corner right here. Probably not what we want it to do. So if we come along here, we'll say, well, what can we do about that? Now, there's different ways that you can calculate your interaction with a wall. You can have an if statement and read your X position and Y position to see if you're getting close to the edge of the screen. But Scratch has a very simple command in here that says if on edge, bounce. Okay, so that allows us to come in here, and when we hit the wall, the ball bounces off of it. And because that's in a forever loop, that will keep on going until the computer shuts down. Okay, so we've got some basic behavior in there. The ball is behaving the way that a ball in a Pong game should behave. We'll add a few other behaviors to it later on, but let's see if we can add another sprite. So we'll come in here and we'll choose a sprite right here. And let's see, did they have a hoop? Can the basketball make the hoops go away? Choose something in here that looks promising. And what would a basketball knock and send flying when it hits it? The basketball will make the baseballs go away. I want something with, let's make the basketball make the clouds go away. I've worked that out. They're called rocks in this drawing, but I can show you how we can edit things up and make some nice, oh, maybe the basketball can make the referee go away. The rocks work really nice. Let's choose the rocks. Okay, now when the rocks come in here, the rocks, as you can see, start out looking like rocks, but we want to change them into clouds for my example. You can come in here and choose the costume editor. Now the costume editor lets you do all sorts of cool things. You can upload your own images. You can edit these. And what I'm going to do is I'm going to take this background right here and I'm going to duplicate it. So now I've got two backgrounds. Now right now they're both identical and they're both pretty big. So I'm going to take that and I'm going to scale it down and make that into a smaller rock right there. And I'm going to take that rock and I'm just going to delete it. And then I'm going to put this rock right back at the center origin right there so that that latches together and it's all lined up. And then for our rock 1, I'm going to make that a small rock. So I'll take that. I'll delete the big one, move the little one right up there onto the center origin, and shrink that down a little bit up and realign that on the center origin. It'll snap right in there. So those two show up in the same place. So I go from big rock to small rock. Now you can come in here and you can edit this up all you want. So if you want to come in here and add a circle, okay, and tell it no fill in there or something like that. Now you can have a circle. Where did circle go? Circle. And why is the circle not latching in right there? Anyways, you can draw stuff in there and you can save it. I don't want that right now, but just go ahead. You can edit up your own file. You've got fill and all sorts of different commands in here that you can use to make that work. If you absolutely need to, you can convert it into a bitmap file. We probably don't need to. Now for the rocks, we've got a couple of different options that we can do in here. And let's come to our code for the rock. And I'm actually going to change these costumes up. I want that to be costume 2 and that to be costume 1 so that we can see that in there. One of your options, because we want lots of rocks, one of your options is just to drag the rock into position and duplicate the rock and put another rock right there. No, sorry. Oh, there it is. Showed up on the screen right there. And you can keep building rocks. I wouldn't do that right now because we haven't assigned any properties to the rock. And anything that we assign to this one, then we have to come along and assign to this one as well. So let's just delete that one. We want to get this rock working properly before we do anything else. Now, the other thing we want to do with that rock is if we don't want to have to go and drag them all out onto the screen right here one at a time, we can have this rock make 50 copies of itself. So let's come back into our code right here. And so let's go to our events. And when the game starts, okay, this rock right here, we're going to move it to a good starting position. And so let's set that to, okay, now up in the top corner right here, the current position of this rock, it says is minus 207 by 158. You can watch that move around as we drag it there. So if you want to know exactly what position you're in, minus 210 by 161. Minus 210 by 161. Okay, so that rock is going to immediately go right to that position right there. And then what we're going to do is we're going to have a loop come along right in here. And our control loop can come in here and we can say, let's repeat 10 times. And we're going to create a clone of that rock. And create a clone of myself. Now the clone inherits all of the properties from the parent object. So it'll create a clone, and then what we'll do is we will move it over by about, let's try 48 spaces. So did we get 10 rocks in there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that makes sense because that one just jumped up there. That's the 11th one, and we don't actually want that one in there. So that's looking good so far. We just drew a row of clone rocks. Okay, now we want 5 rows of clone rocks. So this made 10 clone rocks for us. So what we're going to do is we're going to come back to control, and then we'll bring another repeat loop here. We'll drag this one inside, bring that right up there, and repeat 5 times. Okay, and now that'll just go back and forth and do it 5 times in a row. If we don't also move it down. So what we need to do is we need to tell it that we're going to move it. We're going to change the Y position. And this happens right in here. So we do this 10 times and then we change the Y position. We want to drop that down, let's say 40 spaces. And then what we want to do is we want to set the X position back to minus 210 to bring it back onto this side of the screen so that it'll create the next row of rocks. Oops, wrong direction. We want to change the Y by minus 40 because we're coming down on the screen. And that's one of the challenges when you go from one language to another and they've got different spots on the screen. There we go. Now there are 5 rows. 40 might have been too much. There's 30. Some nicely packed rocks there. And we end up with this one extra rock left sitting right here. And this is our master rock that's been creating all of these clones. And so what we want to do is we just are done with that one and we don't need it there anymore. And there is a hide command tucked away in here somewhere. And if we scroll around, there is our hide command. And now, let's stop that. Oh, everything's hiding. Problem, because I hide it when I come to the end right there. That needs to be outside of that loop. Otherwise, it hides too soon and we don't get to see anything. Well, right now, it's hiding all of them for us. So we need something to tell these rocks what to do when they're created as a clone. Okay, so what we're going to do is we are going to come in here and there is under our control a when I start as a clone option. So this is when it starts at the beginning of the game, but when you initiate a clone, so when you fire a cannon or something like that, you would create the cannon shot as a clone of the original prototype cannon. And so we can come in here and we can say when I start as a clone, show me. And there we go. Now we've got all of our rocks showing up here. And as soon as they become a clone, they turn themselves back on. And when this command is all completed, it hides itself so we don't have that one little cloud that we had hanging out right down here. Okay, now each of these is going to have a property, and that property is that it doesn't like being hit by a ball. So we need to test to see if it's going to be hit by the ball, and we need to do that every frame. So we're going to need a forever loop right in here. Okay, so this forever loop comes in here, and there is a place in here sprite clicked when the backdrop switches, so we can put a background in behind there if we want. Um, you can have different objects send messages and other objects receive those messages. So the ball can tell these what to do, or the clouds can tell the ball what to do. You've got a few options in there, which is sometimes useful. What we're looking for is our basic collision check. And so switch costume to rocks. We're going to need that in a moment. And let's see in here, move, change by X. And again, this is one of my things about Personally, I'm not that crazy about drag and drop interfaces because you have to spend so much time looking for your commands until you memorize where they all are. And when I started clone, create, delete this clone, touching mouse pointer. Oh, there we go. Sensing. When touching, let's try this. Okay, so we'll need an if statement. So under control, if touching basketball, okay, then right now I'm just going to make it make a sound. So what we can do in here, we've got sound in here, and we can, we've got a couple options with our sound. If we say play sound pop until done, it'll pause until the sound's finished. So we just want to start the sound and the game will carry on while that carries on. So let's stop what we're doing. And well, that was annoying. Yes, let's stop that right in there. Well, that's because we're not bouncing off of it. We've got the sound working, but how are we going to bounce? Now, unfortunately, there's not a nice, easy bounce command in here. The only time you see bounce is if you're actually touching the wall. So what we're going to do is we're just going to change our direction. And we've got a couple of different ways to do that. But one way is we can point in direction. And if we know what direction that we hit it at, then what we can do is we can come down in here and we can do a little bit of math. And you've got your math features all down at the bottom. And we know that whatever direction we were heading, so now we have to scroll all the way back up here to get our direction, point direction. We'll build this little command outside and then drag it in. And we'll change that direction plus 180. And drop that right in there. Okay, so now oh, that's the direction of the ball. We don't want that. We don't want that there. The cloud's not going to change direction. That would be silly. We need to add something to the ball. Okay, so let's come back to the ball object because that is a ball behavior if it's on the edge that it should bounce. Well, in here, we can also add the if touching cloud, if, and where was our touching? Oh, it's called rocks right now. So if the ball is touching the rocks, then what we're going to do is set the direction, point direction. Then we come down here and we grab our math. Then we put our current direction into the math. We add 180. Thankfully, I finally get to use the keyboard for something. And we drag it right in there. So now it should test and see our rocks are behaving strangely. Let's just come back over here and see what happened to our rocks. It's like their direction is changed around and they're all pointing in the wrong direction. So we may have to, when we initialize it, set that direction as well. And let's see what happens if we tell it point in direction 90. There we go. Oh, our ball got in there too quickly. It moved too fast. And it's hitting those rocks. So we need time for the rocks to finish building out right in there. So we don't want that ball to start moving right away until those rocks are done. So we come back and take a look at our ball and we say, okay, well, the ball needs to wait before it starts moving. So there is a command in here that tells us to make the ball wait. Where are we down here? There we go, under control. We can just put a little 1 second delay in there. Now the ball waits and the rocks have a chance to grow. And now that's working better, but we're not getting the pop sound from the rocks. Well, as far as I can tell, oh, that's a problem with the collision detection engine in Scratch. Now, like I say, Scratch is an awesome learning program, but every now and then you do run into little problems where it doesn't detect a collision quite as sophisticatedly as something like GameMaker, also another object-oriented game programming language, but more intended for commercial use. Scratch, intended for learning use, it does a good job of what it does. Okay, so we've got the ball bouncing around in there. We've got the pop sound happening. We've got collision detection happening on the ball that causes it to bounce. And we've got collision detection happening on the rocks that cause them to make a pop sound when they're hit. Well, what we also want them to do is we want them to change their costume. Now we've got different costumes in here, costume 1, costume 2. So what we can actually do in here is there is a way of controlling our various costumes, and we can just tell it to go to the next costume. Now, what that should accomplish for us is that, there we go, when they get hit, but now instead of disappearing after the next hit, they come back larger than ever before. So now we've got a couple of ways of solving this. One would be to add a third costume. So the third costume would have absolutely no pixels on it. And then it would just go large cloud, large rock, small rock, whatever you want to call it, and then it would disappear. So you could have 3 costumes like that. Or what you could do is you could actually have a test in here, and if the costume is the small rock and it gets hit, then you could just make that object disappear. That's probably programmatically the most efficient way, because as you keep hitting them, you get fewer and fewer rocks having to check for collisions. So you can add an if statement right in here, and you can say next costume, and you can say then start sound pop, if then we want the if then else. Okay, just gonna put that in there. So if okay, and then we'll come down here and we've got a equal sign, and then right in here we can put in costume. We have a value for our costume right here. If our costume number, okay, equals 1, then we go to the next costume. And if it doesn't equal 1, then we can hide that object and make it disappear, because our options are that when we get hit by the basketball, then if we're in our initial state, which is costume 1, we'll go to the next costume. And if we're not in the initial state, then we've already been hit once and we can hide that. Let's see how that goes. There we go. Now they start disappearing. And it looks like our collision detection's working pretty good at that impact angle. I just want to see what happens when we get up inside there and go for the massive Pong wall of destruction. Interesting. There we go. We missed a collision right there, but we got right there. That worked pretty good. Missed a collision right there. Again, a few little glitches that you might run into in the game engine. So it looks like now we've got our ball behaving the way we want. We've got our rocks behaving the way that we want. And now we need to get something to bounce that ball back and forth. So we're going to add another sprite. And what would be better for bouncing a basketball around than an elephant? A heart face. Take a look on here. A muffin could do it. Oh, a rainbow. I like the rainbow. Okay. And the rainbow's looking a little bit big, so let's come into our costume editor right here. And let's just see. Oh, now the rainbow, we want to take the rainbow. Let's take all the colors of the rainbow, so draw a box around it and just shrink them down a little bit. Okay, there we go. And there is our rainbow right now. Okay, and let's take a look at some of the code for our rainbow. Well, again, our rainbow is going to start out at the beginning, and we're going to have to give it some instructions. So when the game starts, we want to give it a direction. And so we are going to move it to go to and down. Again, this is 0, 0. We've got a screen that is 480 wide. So this is minus 240. This is plus 240. We don't want to come right to plus 240 because otherwise we'll be at the bottom of the screen. Let's see what happens if we try. Well, we want to set it at 240 for the middle of the screen. It's 360 up and down. So we're looking at either plus or minus 180. Let's try setting that up to minus 150. And let's just see what happens right there. And right, that's 0. I keep getting my Scratch coordinates mixed up a little bit. But again, Scratch is pretty forgiving and it lets you play with those coordinates. Okay, so that gives you an initial starting position for your nice bouncy rainbow. And what we're going to do right here is we're going to come in here and take a look at it. And we have to come back to our control and give it its forever loop. And to get some keyboard input, we can say if, and let's bring a condition down here. Let's see, let's pick up a condition on here. There's a key condition. Kind of drop the lead of it in there. And let's pick the left arrow is pushed, so that's going to move it this side on the screen, which should decrease our X position. Then what we can come up here and we can say, then let's say change X by, and to move left, we want that to be minus 10. So let's just click on that and see if that works. There we go. By just clicking on the green right there, I'm only testing one of the objects, and it only goes that far and then it stops. Okay, now I've got no way to come back. So what I can actually do is I can take this little segment, duplicate it, bring it right down there, put that back in there, and then I can say if right arrow is pressed, then I can change it by positive 10. I can drop that right in there. Just be careful where you put it. If it goes in there, then it only actuates if this condition is true. So just like the rounded brackets in Arduino, the ellipses, the squiggly brackets in Arduino control what controls what, you need to watch these little huggy bits right in here. And let's just test that. And we're running that right now. We can go left and right now. Now, if you're happy with it going off the screen, that's fine. You can let it go all the way off the screen like that. Scratch stops it from going too far. A lot of game engines will let you just keep on coming until it comes all the way out here. Um, Probably not a big deal. One more if statement in there, as you'll see if in that initial game that I had, will take that under control. Okay, so that's moving left and right now. And now we want some interaction between the ball and the rainbow. So let's come back to the basketball. And so we had good luck with the if touching rocks. So let's just drag that out of there for a second and let's duplicate that. Put that back in there and put that right in there. And let's try rainbow. And so this should change the vertical direction if we're touching the rainbow. It's not going to work out perfectly, I don't think, but let's give it a try. Now you see what happens there is if it comes in from the side, kind of got overlapped on the rainbow because the rainbow was moving in right there. And because we're moving 10 game spaces per unit, if we run in from the side like that, we can capture the ball. But the general game fundamentals are starting to work. There's a few little glitches in there, like we're catching that, and maybe we're not bouncing at just the right angle. We'd like to be able to use the rainbow to control the direction of bounce, like that one right there, where it comes in there and it's a complete change in direction. That's not a natural bounce right in there. So that's something that I think you could probably figure out if you want to take this game and make it work better, is how do you control that direction of bounce? What do you do? How would you capture the fact that the ball is going to hit the bottom of the screen at some point? Okay, what would you test for? Would you test for its position? Seems likely to me that if it gets too low on the screen, you're going to want to have some sort of consequence happen for the player. How would you keep score? Okay, Scratch has down here variables. So if you scroll down to the bottom, you could pick out some variables right in here, and you could use those variables to show them on the screen somewhere. You can create functions in here and make your own blocks. And most importantly, you can follow some of the tutorials and look at some of the examples that many other people have created. When you're all done with your project, come up here to File and tell it to save now. Okay, that's still called Untitled. Let's give it a better game. We will call that Pong the Rainbow. And we'll save that. Okay, and then you can go to the, click on the Share page. And that means that you can share your project. So that's a good way to share it with people. You can put a little note right on here that says what it is, okay, and tell people how to take a look at it. And then once you've done all that, oh, we guess we have to give it some instructions. Oh, I hit the wrong key on the keyboard and got into HTML editing mode. That has nothing to do with Scratch and everything to do with my web browser. Sorry about that. Let's come back here to, there we go, Pong the Rainbow. Let's come back to share, see the project page. It's been shared. And once you've shared it, then click on copy link and you can take that link, copy that, you can email it to anybody. You can post this on your website, in your Facebook feed, whatever you want. And anybody running a web browser can not only run your program, but they can come along and they can see inside your program. So if you're getting stuck, they can offer help. Or if you've done something really cool, you can show that off to them. So that's a simple little introduction to the beginnings of what Scratch can do. There's a lot of other things that you can do with it and a lot more different ideas that you can come up with. If you enjoy working with Scratch, you might also be interested in using a similar a programming language called GameMaker. That's from a company called YoYo Games. And if you look over here, you've got all your sprites right over here. This is a little tutorial that shows you how to create an asteroids-based game. And you could probably take some of the information from that tutorial and make an asteroids type game in Scratch as well. So these languages are well set up with tutorials. The advantage of GameMaker is it's got really good educational pricing. It gives you a 28-day free trial, so you can try it out first and find out if you like it. And if you do like it and you do create a game, what you can do is actually you can compile that game and you can export it to Windows or Android or Mac or any system, and you actually get a game that stands on its own, runs by itself. You've got more advanced collision detection, larger screen sizes, and just a whole bunch more. This is kind of like the professional package compared to Scratch's learning package. Scratch is excellent as a learning package, but if you like it and you want to move up to the next level and you like this style of programming, I think you'll really like GameMaker. All right. Thank you very much and have a nice day.